When we're solving a quadratic, okay, there are different methods when it comes to solving, but the first one we're going to focus on today is solving by graphing. But before we get into the graphing and how that's one of the methods, we need to talk about what a solution looks like, okay? So first thing I'm going to have you write down is a solution to a quadratic is where the quadratic or the parabola touches or crosses the x-axis. Okay, it's where it touches or crosses the x-axis. So we have three options, and this will happen regardless of the method that we're using. Okay, we'll get into those three options in a second, but other names for solutions, and it depends on the context, but you might see this in other courses. A solution, I'll put down other names. Solution might be called a zero, a root, or simply an x-intercept. Okay, you use the y-intercepts when we're graphing linear equations. You actually use those to graph. There is a way algebraically to find those with quadratics, but we're finding them by actually graphing. Okay, so the options that might happen is the parabola crosses the x-axis twice in two spots. So what that could look like is the vertex is below the x-axis and the parabola opens up. And it doesn't have to be centered around the y-axis, but the vertex could be above with the parabola opening down. So in both of these cases, our solutions would be either here or there. So the two spots where the parabolas cross the x-axis would be what we're looking for. Okay, and if you cross the x-axis, that means y is 0, right? So both of those solutions would be in the form x 0. And there would be two of them. All right, so that's what it would look like if there are two solutions. The second option would be when the parabola touches, right? A teacher once that would say it kisses the x-axis. That means the vertex of the parabola is right on the axis. So we could have a vertex here with it opening up, or the vertex touches and it opens down. And again, that vertex could be anywhere on the x-axis. Okay, Now this could open up as well. I don't want you to think that when it opens down it's on the y-axis, and when it opens up it's not. Okay, these could move right or left, any of them. Okay, but in this case there's only one solution. It could be 0, 0, or it could be x, 0. And then we have actually a no solution option. So what do you suppose happens when there's no solution? Oh, there's always a graph to a quadratic. But remember, if the solution is where the quadratic or the parabola touches or crosses the x-axis, how can there be no solution? Any ideas? If my vertex is above the x-axis and my parabola opens down, will there be a solution? There will be two. But what about if my parabola opens up? Will it ever touch the x-axis? If the vertex is above and my parabola opens up, there will not be a solution. My other option would be what? If my vertex is below and the parabola opens down. Now, when we're solving a quadratic, you always want to make sure, because these functions, okay, are in the form y equals ax squared plus bx plus c. If you don't have all the x's and all the non-zero numbers on the same side, you want to get them on the same side. Okay, they need to be in the standard form. All right. So we're actually going to put this on the graph paper this time. This is the first method out of a few that you're going to learn for solving. First step is we're going to graph the function. And I would not do graphing if there's a b involved, because there are going to be other methods that you can use. And when we graph, it's kind of like looking for the solution to a system of equations. Graphing isn't always the best method, because if your intersection isn't at whole numbers, it's kind of hard to tell what the numbers would be. Okay? But in this case, we're going to start with, okay, so graphing the function. We're going to do y equals x squared minus 4. And that is solving x squared minus 4 equals 0. Okay? The related function is replacing the 0 with y. And once we have the graph, we are going to look for the x-intercepts on our graph. So the thing to remember here is if you start your graph and the vertex is below and you haven't graphed enough points so that you have points above the x-axis, you need to keep going because we need that intersection. All right? So if we're graphing y equals x squared minus 4, okay, this should be a quick one, and like I said, I wouldn't graph them if they're not quick because there are other methods. What do we know just by looking at this function? Can I pick out the vertex from this? What is the vertex? Zero, -4, right? There's no b here. So if I did negative b over 2a, b would be 0, and then it doesn't matter what a is because my axis of symmetry is at 0. So 0, -4 is my vertex, and I need a couple other points. This is going to open up, right? So my vertex is below the x-axis, and it's going to open up. I should have solutions. So let's do -1, -2, 1, and 2. So if I plug in 1 and I square it, so 1 squared minus 4 would be 1 minus 4, which is -3. I'm still not at or above the x-axis yet. But if I do 2 squared minus 4, 0. That's kind of what I'm looking for, okay? So when I graph this, I'm at -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. So there's my parabola. And since I'm looking for the solutions, or where it crosses the x-axis, those would be right here, yes? So these are my solutions. And sometimes we get the solutions in the form that would not be an ordered pair. So sometimes you'll see them x equals 2 and -2. Because the solutions are at y equals 0 anyways, okay? So that's kind of what we're looking for. Okay, we're going to look at another option. What is the vertex? It is 0, 3. So we're going to pick a couple other points. So if I do 1 squared plus 3, what do I get out? 4. And 2 squared plus 3 is 7. And are you noticing something about this? Or did you already know it when you looked at that? Will this have any solutions? Let's graph it and see. I'm going to say no. And I'll tell you why in a second. 0, 3 is my vertex. There's 1 and -1 at 4. Any solutions here? No. Okay. This is a no solution. Now, I knew that the minute I looked at that function. Does anyone know why? Well, besides that, where's my vertex? Above or below the x-axis? Above. It's up 3, right? And will my graph open up or down? It'll open up. So if my vertex is up and my graph opens up, is there any way that this is going to cross the x-axis? So I didn't even have to go through the table and the graph. if you know the vertex is above the x-axis and it opens up, or it's below the x-axis and it opens down, you don't have to do the graph on those because there's not going to be a solution. You would have to do a little bit of an explanation and say the vertex is at 0, 3, and the graph opens up, no solution. Okay? But you don't have to go through all of this work. A simple explanation would be good enough. Okay, so instead of all of this, I could say vertex is 0, 3, parabola opens up, and then put down that there's no solution.